So you're recording a video, guys. I want you to get ready to do this on Monday. This is measuring density. So what I want you to do is I want you to take this, there's a wood block that I'm going to give you. It's 0.75 inches on all sides. So we're going to find the volume in that in just a second. So what I want you to do is I want you to come over here and drop this wood block. Now you can already see I've got one in there. If you'll notice, it's floating, right? It's floating on the water. So the density of the water is heavier or more dense than the density of the wood cube. So if I drop this wood cube, you can probably tell what it's going to do. It's going to float, right? It's not going to sink. Obviously, it would float either way. But it's less than water. The density is less than water. So density, what is it? So come over here just a second. I want you to see this. All right, so I'm going to write down the formula that you need to know. Density equals mass divided by volume. The way I remember this is, remember DMV. So like when you go to the DMV and get your license or whatever, it helps me remember density equals mass times volume, DMV, just like that, okay? So now, first thing, I want the density of the water, okay? I'm going to prove to you that the density of the water is more dense than the density of the block. Can you do me a favor and pause? Hey, this water is in milliliters. So if you look really close, let's see if I know if you can zoom in on this. But you'll see some numbers here. You got 30, 50, 70, 90, 110. Well, this one I tried to measure out to be exactly 100 milliliters, okay? So what I'm going to do is I'm going to write that down. My volume on the bottom of my fraction is going to be 100 milliliters. All right, now I need the mass. The issue is mass is measured in grams, and so when I cut my scale on here and I set, like if I have an item on here, like let's say for instance if I've already got one on there, you'll notice that the numbers jump up. I can push tare and it sets it back to 0, and then whatever else I add into it adds weight, okay? So if I pull that off and push tare to set it to equal to 0, what I can do is put stuff on it. So pause just a minute. Mass of this empty cylinder, okay, empty measuring. All right, so it's, if you'll notice it says 2.8 ounces. I need to change that, so I'm going to change the mode. I need it to be in grams. It says it's 80 grams. So that means the mass of the empty, all right, let me write down empty. When it's empty, it's 80 grams, right? So mass is kind of like weight, okay? So here we go. If I take this off and put one that's equivalent to it in weight and then add 100 milliliters of water into it, I should get about 180 grams. If you'll zoom in right here just a second. See, it says 180 G. That's grams. All right, so now we'll come over here. Let's see. Full is going to be 180 grams. So what I want to do is I want to figure out how much the water itself weighs. So I need to measure, take away the weight of the empty container, and that will give me the amount of the water, the grams of the water. Okay. So we're going to subtract these. We're going to get the difference of these, and so 180 take away 80. Well, that's 100 grams. All right. So 100 grams goes on top of the fraction where it says mass here. So density equals mass over volume. So here's my mass of my water, okay? And so I'm going to put 100 grams over 100 milliliters. So grams per milliliter is how you measure density. All right, so what's 100 divided by 100? That's 1 gram per milliliter. So the density of water can spell water, okay, is 1 gram per milliliter. Okay, pause it. Wood block, not the water. And so we're going to use the same formula, and you know we're going to need mass, so I'm going to go ahead and click that on, and we're going to find out now. Right now it's set to 0 ounces. I need it to be grams, 0 G. I put this block on the what scale, and I get what, 5 G, right? All right, so where am I going to put that on my formula? So we're going to get the density of the wood block. So I want to put WB for wood block equals mass over volume. Well, it's not going to go under volume, it's going to go under mass. All right. So mass of the wood block is 5 grams. So now I need to figure out what the volume of this is, and the way you find the volume of this is you measure it. Well, if you take a pair of dial calipers, what this is supposed to average out to be is 0.75 inches of here, here, and here. So length, width, and height, okay, or depth. Now, so what we're going to do, so we're going to say the volume is 0.75 inches, all raised to the third power, because you're multiplying it times 3. So pause that real quick. The density of the wood block, but the wood block's measured in inches. I need to show you, let's look at this just a minute. The density of water is grams per milliliter. This is grams per inches cubed, okay? So we need to figure out how to make inches cubed turn into milliliters, and there's an easy way to do that, but it's called Google. So we're not going to use Google, we're going to do it the hard way, all right? So what we're going to do, first things first, if you multiply 0.75 times itself 3 times, what you're going to find out is you get 2.25 inches cubed, okay, just like that. So this, the volume of this in inches is 2.25 inches cubed. I need to get inches cubed to turn into milliliters because we need to measure the density exactly. And so if you've ever heard of a medical term called, like say, if you get an injection, if you have a family member that's a nurse, they'll give you an injection that of maybe 10 cc's of, you know, whatever, you name the vaccine. But 10 cc stands for 10 cubic centimeters, and we can change inches cubed into cubic centimeters. So what all we need to do is come over here and convert inches cubed to cubic centimeters. And so what I want you to do is take 2.25 inches cubed, and we're going to see how many cubic centimeters that is, okay? So pause it real quick. I'm going to paper here that I'm going to give you at the end of the month, or at the beginning of May, is this is your engineering formula sheet, and you'll go to page 3 on your engineering formula sheet, and you'll look under length here. It says 1 inch equals 2.54 centimeters. Well, I'm going to use that to convert inches to centimeters, okay? And so if you come over here, remember I said centimeters cubed is equal to milliliters, okay? All right, so centimeters cubed is equal to milliliters, and that's volume. That's just a different unit. So we're going to convert inches to centimeters. So here we go. What we need to do is we need to set up a proportion, okay? I want to know how many centimeters cubed that is equal to. So what I need to do first is figure out how many centimeters is in 1 inch. But the problem with this is this is inches, not cubed. This is centimeters, not cubed. So we need to cube the inches and then cube the centimeters. So what I'm going to do is put a parentheses around that and cube, put a parentheses around that and cube. So now when I multiply this out and I cross multiply it out and solve this proportion, what I'm going to wind up with is centimeters cubed over centimeters cubed, inches cubed over inches cubed. So pause just a minute. Hey guys, bring your chatting down. So the easy part is to come over here and just start multiplying, cross multiplying like this. So we'll say 2.25 times 2.54 cubed, and then the other side is going to be 1 cubed, which 1 cubed is 1, times x. So I'm going to put a little dot x like that. All right, so now let's solve for x. And so let's pause it just a sec. Here, when we multiply this, is we get 36.87, is that right? 36.87 equals 1x. So that's 1 to the third power, which is 1, so that's 1x. I don't have to have the 1 there. It doesn't matter. So what is 36.87? 36.87 is this x right here, okay? So 36.87 centimeters cubed. So what do I write down over here? I can convert, I just converted 2.25 inches to the third power into 36.87 centimeters cubed, or 5 grams over 3.687 milliliters. Remember, these are two interchangeable terms, okay? So now all we need to do is divide 5 by 36.87 pause. All right, so okay, first off, let's recap what we did. We got the density of water, which was 1 gram per milliliter, right? Now we are calculating this, which Kira, can you read that number out to me real quick? Was it 0.1 what? All right, let me see the phone there. All right, zoom in on that right there. 0.1356. That's grams per milliliter. That's the density. So now back up. Oop, you just got to take my teeth. All right, so what we're going to do? Check this out. I'm going to point right here. I want you to see this. Okay. So water is 1 gram per milliliter. The wood block, that's this thing right here, is 0.1356. This is less than this. That's why, if you'll shoot over here, that's why this density is lighter than the water and it floats. Okay, anything that's lighter than 1 will float. Anything that's heavier than 1 will sink. So if I put like a coin or a penny in there, it would sink. All right, so now that's it. Okay, pause it.